Okay, so here we go again. We're going to continue with our videos and functions. And what we're going to do here in this video is we're going to give inside some examples of functions. So again, to be a function means no two ordered pairs or a set can have the same first coordinate and different second coordinates. So this means if we're going to write this, if we're going to draw a vertical line, it should intersect only once, given the graph of the function. Or if you want to have a rule or a formula giving y in terms of x, and there is no more than one value for y for each value of x. So then y is said to be a function of x. So for example, so let's say, for instance, let's take example 1 here and say we have a function f of x which is equal to 3x minus 1. So say we are tasked to find different values of x, or rather different values of the function f of x. Say for example, we're asked to find the values f of minus 2, b is f of t, and c is f of t plus 1. Let's have that. Okay. So to start with, let's what we're gonna do is we're just going to convert actually. We call this evaluation of functions, and what we're gonna do is just to evaluate the given values of x. So for letter A, we are actually seeing the value of x as in we're going to let it as -2 or -2. And then what we're gonna do in this given this function over here, we're going to substitute all the values of x on the right hand side to be equal to -2, and then we'll see what we have. So what we have is f of -2 will be equal to 3 times -2 minus 1. So what we do is the arithmetic then. So what we'll have is -6 here minus 1. So remember, they have the same sign, so we're going to add, and what we'll have here um, is going to be -7. So that's your f of -2. Secondly, what we have is f of t. So in short, we're going to let all the x's be equal to t. So what we have for our f of t, so since we just changed the variable x into the variable t, so the function of y to the variable t will just be changed into t, which would look like this. So I think we're done there. The last part will be we're going to let x as a binomial. So we have x is equal to t plus 1. Hence, what we have is for the f of t plus 1, what we have is going to be a variable for all the values of x on the right-hand side. So we have 3x minus 1. So hence, we have 3 times quantity t plus 1 minus 1. So let's do the distribution of 3 here. So we have 3t plus 3 minus 1. So what we have is going to be simplified into something like 3t plus 2. And that's going to be the function of our f of our y t plus 1. And then that's it. Okay. Um, Next would be let's have an example wherein just like previously from the previous video, we're going to convert an implicit function into an explicit one. So let's have this. I'm gonna scroll down and we're gonna have this example 2 here. So for example, for instance, you're given the implicit function for 4x minus 3y minus 12 equals 0, and we are tasked to change this into an explicit function into something like it will end up with f of x equals something or y equals something. So for the solution of this, let's do this algebraically. And our main goal actually here is to isolate y. That's going to be our main goal. Isolate y. Okay, since we want it to be an explicit function, so we want to isolate y, and if we can, we could actually make it f of x. So from here, what we have is, well, first step would be transpose this other term to the other side, also this other term to the other side. So what we have is we have 3y left, or negative 3y to be exact, on the left hand side, and what we have, since it's 0 gonna is here, so we have positive 12 minus 4x. Remember, the signs change when we transpose them to one side of the equation. Then we would want to isolate the y completely. So we can see that it has still has this coefficient of minus 3. So we want to cancel that. Hence, we will be canceling minus 3 to the whole equation term by term. What we have is going to be, this will be canceled clearly. So we have y equals, this is going to be negative since one of the signs is negative. So we have y equals negative 4. So they're both negative. So this is going to become positive. Positive 4/3 x. Okay. Then I think we could just, we can just fix this. Remember that this is f of x as well, and we can make the 4/3 on as the first term minus 4 to make it look better. Anyways, this one is already correct, so you can have this as your final answer. But if you want it to be in the proper writing wherein the terms go first, as in the definition of a polynomial function, so I think this is the one better way to do it. Okay, another example, let's say, let's have a line here. So example 3 then. So example 3 tells us to have this f of x equals 2x minus 3. Okay, so we have that simple linear function. And we are tasked to find what is f of 2, question mark, and what is f of minus 5 or negative 5. So let's do it. So solution. So again, our goal here is, this is evaluation of functions, so we just want to evaluate the value of x as 2. So what is our f of 2? Uh, so our f of 2 would be something like, substitute all the values of x on the right hand side for 2. So we have 2 times 2 plus 3. So we have 2 times 2 plus 3. That's going to give us 4. 4 plus 3 is going to give us 7. So our f of 2 is going to be 7 in that example. Next up is going to be f of minus 5. So f of minus 5. So substitute all the values, all the x's from the right hand side into 5, or negative 5 to be exact. So we have 5 times negative 5. That gives us, and then plus 3. So 2 times negative 5 is negative 10, plus 3, that's going to give us negative 7. So that's our answer for f of negative 5. Okay. And say let's have this last example, shall we? So our last example will be something like not a linear function, but you get the gist of it. So let it be a quadratic function. So our f of x looks like x squared minus 2x plus 1. So we are tasked to find f of 0, which is a question mark. Let's answer that. Let's give a solution. So our solution for this is going to be, let all the x's on the right hand side become 0. So we have f of 0 is going to be 0 squared minus 2 times 0 plus 1. So by the zero property of multiplication. Any number multiplied by zero is gonna become zero. This becomes zero. This becomes zero as well. So what we have is one as our final answer. Okay. So I think we have seen four examples now. I think it's time to end the video, and I hope you learned something from this. We'll be seeing you in the next video, definitely, to talk more about linear functions and stuff. Okay, so thank you very much, and see you.